So I'm using a Linux terminal at the top and the cluster shell at the bottom, and I'm going to be using vol.y from the Linux terminal, which is an NFS mounted volume from the cluster. So I'll be creating files and creating snapshots and then restoring the first snapshot, which will result in losing snapshot 2 and losing the second file. So first I go to the mount point of svmred, then I will go to vol.y, and I'm going to create a single file, which is file1. I list it and I see I've got file1. Then I look in the snapshot directory and I see it's empty, so there are no snapshots. Then I will create the first snapshot, which is called snap1 for svmred and volume vol.y. After I've done that, I can go back to the Linux terminal and I add a second file, file2. I list both files, and now when I look in the snapshot directory, I will see that there is one snapshot which is called snap1, and I list the snap1 directory, and there's my file. So file2 is not in there because it wasn't there when the snapshot was created. Then I create the second snapshot, snap2, which will hold file1 and file2. So I list the snapshot directory contents, and there's snap1 and snap2. Now I list snap1 again, it's still only file1, and file2 will hold both files. Now I'm going to restore snap1. So I enter the storage virtual machine, I enter the volume name, and I want to restore snap1. Now it gives me an interesting message. It says if you restore this snapshot, then you will delete all copies that were made after it. So I'm going to promote, as they call it, snap1 to become the active file system again. Now it gives me another warning on quota. I'm not interested in that right now because we're not working with quota, we're not busy with quota. So I'm going to confirm that, and it will also complain about export policies and queue trees. So we are not interested in that either, so we simply confirm. Now that I've restored snap1, if everything is okay, snap2 should be gone and file2 should be gone. So file2 is gone. It's no longer there because I restored snap1, and in the .snapshot directory we will only have snap1 left. The other snapshot is not there anymore. And we're done with the first demo. Now to restore a single file, we have the same situation. So we look at the contents of file 1, it says hello. Then when we look at the snapshot directory, we still see that snap1 is available and the file is in there. So now we're going to change the contents of the file to by. So we echo by to file 1. And so the snapshot still holds hello and the active file system says bye. Now we do a restore of the file. So we run snap restore file, and of course we enter the storage virtual machine's name, then the volume name, and finally the snapshot. And then we have to enter the path. And the path name has to start with /vol, which is used to access snapshots. So we run /vol vol_y, which is the volume, and the file is file1. And now it has restored the file, and if we check, we will see that file 1 contains hello again. And we're done. The next thing we do is we will restore a single block from a file of, in this case, 8 kilobytes. So first let's have a quick look at the file. We've got a file called file XY and it's 8 kilobytes in size. Now we'll check the contents of the file first. We use the more command for that. Now I have filled this file with X's and Y's, and the first 4K contains X's and the second 4K contains Y's. More will tell us page by page. So we see 13% of X's, 26% of X's, 39, and then after 4 kilobytes it changes to Y's, all the way to the end of the file. So 4K of X's and 4K of Y's. We check the snap directory and we see that it's empty. So we have no snapshots. So first we'll create a snapshot, and then we will change all X's into Y's. Then we'll restore the first block of the file from snap1 so that it contains X's again, because that's what's in the first K block. So let's first create a snapshot. So we run vserver svmred vol snapshot is snap1. Then we check the snap directory and we see that snap1 is there. And in snap1 we see the file. Now in Linux we can change the contents of a file using the stream editor. So we run sed stream editor sed-i, and we say that we want to substitute each and every X into a Y. The G at the end takes care that we change every instance of X in the entire file. So on every line where it finds an X, it will change the X into a Y. So now when we run more again, we should not see any X's but only Y's. And indeed, the first block contains Y's instead of X's. So it's Y's all over the place. So now we're going to restore a single block with X's. So we run snap partial restore file from svmred vol snap1, and we enter the path. So now here comes the tricky bit. We enter a start byte of 0 because it's the first block, so it starts with 0. And then the byte count has to be a multiple of 4 kilobytes. But we only want to restore the first block, so because that contains the X's. So we enter 4K. And when we check the file again, we see that the X's have been restored. Mind you, what actually happened is that the pointer to the first block was reset to the block that holds the X's. And we're done. Now let's have a look at what happens when a CIFS or NFS client restores files into the volume from the snapshot directory. First, the client has created some files, then it will check the space, then we will snapshot the volume, the client will remove some files from the active file system, check space again, and then the client restores files and checks the volume space again. Now remember that the client that restores a file will always need space to restore that file. So first we make sure we are in the data directory, then we run du-sh, and it tells us that we have a little over 100 megabytes of blocks in the active file system. Then in the cluster shell we run the df command, and it tells us that the snap space is not allocated and we have about the same amount of disk space that's in use in the volume. Then we create a snapshot and we are going to call the snapshot snap1. Let's just do that. So it's called snap1. And after that we check the space in the volume from the cluster shell. And it tells us that there's a little overhead in the snapshot space. So that's just some blocks. The actual file system is still 108 megabytes. And for the client that's the same. So the active file system has not changed yet. Then the client removes all the files from the volume. So we do a listing and the volume is empty. Now when we look at the blocks that we have in use in the active file system, that's just the one block that is used for the directory itself. But then when we run df, it will tell us that we have 100 and somewhat megabytes in use in the file system, which is not the active file system, but it's the snapshot that takes the space in the file system. So then when we look at the cluster shell, we see that all these blocks are in the snapshot. So the client may think that he has removed a lot of files, but he actually did not free up any space in the file system because we have a snapshot. And then in the exported file system, we look in the .snapshot directory of the volume, and we list and we see we have the snap1 directory, and inside the data directory we will find all the files that we have removed from the active file system. But because there's a snapshot, the blocks cannot be freed. Let's copy all of the files from the snapshot back into the active file system. So this is restoring from a client perspective, and all these files will be created inside the active file system as new blocks. So what will happen is you will get new blocks that are allocated inside the active file system, and the snapshotted blocks are also still locked, obviously, because the snapshot has not been removed. So we go back to the active file system from the client, and we check whether the files are back, and we see that the files will have been restored. Once we're in the active file system again, we run ls, and all the files are back. Then we run the df command again, and we see that we have twice the amount of space which is in use now. And half of this will be active file system, the rest will be the snapshot. So let's check the volume space from the cluster shell, and we see we have 106 megabytes in the snapshot, and in total the file system will use 214 megabytes in this case. And we've only got 35 megabytes available. And we're done with the first part. Now let's have a look at the following. The client will restore a single file, which will be the same as restoring all of the files, so that will take space. Then from the cluster shell we restore a single file, but now to a different name. Does that take any space? So we run the df command on the client, and we see we have 250 megabytes available, so we cleaned up the entire environment, and in use only 192 kilobytes. We run the df-h command, and we see no snapshots, and also we have 250 megabytes available. Then we copy a file, and the file is called file, and it's 40 megabytes in space, and we have copied it inside the vol.y directory, which is the volume. And as we can see, we've got 40 megabytes in use in the active file system. And there's no snapshot yet, so we create the snapshot again, and let's call it snap1. So we run a second snap1 snapshot, and we run a df listing, and it'll tell us that the snapshot only takes some overhead. Because there's no blocks that have been removed from the active file system, the snapshot does not take any space. So now from the client we are going to copy that file from the snapshot directory into the active file system, but then with a different name, and see whether that takes any space. Obviously it will, but we just want to prove it. So we copy the file back into the active file system and call it file_copy. So then we run the df command, and we see that we have twice the amount of disk space in use in the file system, and the du command tells us the same. So copying back a file under a different name will take additional space. Now we do a snap restore from the cluster shell, and we will restore it under a different name as well. This, however, by the way, differs from WAFL in 7 mode, where it would take space. In clustered on tap, it does not take any space when you restore a file with the snap restore file command to a file under a different name in the active file system. Let's just check that. Now the df command will tell us that we have no additional blocks allocated. This is because we're using the pointers to the blocks in the snapshot. So the amount of disk space in use has not changed, but when we run the du command, that we have another 40 megabytes of allocated blocks in the active file system, because the pointers from the snapshotted blocks have been restored to the active file system. So let's clean up and then we're done with this demo and with this module. So what we've seen is that snapshot creation can be manual or scheduled. Snapshots will not take any space until files are removed from the active file system. Clients restoring files from a snapshot does take space, and using the snap restore file functionality does not take additional space in the active file system. And you can restore volumes, files, and even partial files. Now the next module will be on space management and storage efficiency. So that's going to be rather a big module. If you've got any questions, please let me know.